Right guys, in this video we're going to have a look at how we do Pythagoras. So Pythagoras is used when you have a right angled triangle. So in my examples here you can tell they're right angled triangles because I have this little square here. So this is saying that this is a 90-degree angle, therefore right angle. And it's a way that we can find a missing length. So in this triangle here, I want to find this length. So I'm going to show you two different ways you can do this. Pythagoras, what the actual theorem says is the sum, so if I add the area of this square and this square, so basically if I add the area of the two smaller squares, I get the area of the bigger square. So that's what I'm going to work out. It's if this length is 3, then the square would be 3 times 3, and that would be 9. So the area of this square would be 9. If I work out the area of this smaller square here, well, if that length is 4, 4 times 4 is 16. Okay, so the area of this one is 9, the area of this one is 16. And Pythagoras tells us that if I add these two together, I'll get the area of the bigger square. So 9 add 16 is 25. So the area of the bigger square is 25. So if you want to work out this missing length here, which I've called x, well, the area of the square is 25. To work out the length of the square, all you do is square root that, which will give you the answer of 5. And because that's in centimetres, it's 5 centimetres. Okay, so that's one way to look at it. The other way is that people might have seen is the formula a squared plus b squared equals c squared, where a and b are the smaller sides here. So this side here and this side here. Okay, so a and b would be the smaller sides. And all you would do is substitute in the values. So a squared and b squared are the smaller lengths. So I would have 3 squared plus 4 squared. And that would equal, in this case, the length is called x. So I'm going to say x squared. So then you just work it out. 3 squared, so 3 times 3 is 9, plus 4 squared, so 4 times 4 is 16, and again I'm going to keep that as x squared. Simplify this, so 25 equals x squared, and then to get rid of this squared, you would square root, so square root of 25, and then therefore 5 equals x. So that's the other way you can look at doing Pythagoras. I'll do both ways for all the examples because I know some people have been taught different ways. Let's have a look at this one then. Exactly the same thing. This one here, this length here is 5, this length here is 6. So I'll do the first way first. Let's work out the area of this square. So 5 times 5 is 25. And 6 times 6 to work out the area of this square is 36. Okay. Now, when you add these together, so 25 plus 36, that's going to give you 61. And again, the area of this big square is 61, but I want the length of this side. So to do that, I square root the 61, and you probably need a calculator for that, but you get the answer of 7.8. That's been rounded. Okay. Again, if I was to do it the other way and use the formula, a squared plus b squared equals c squared. Substitute in the values for the smaller lengths, well, 5 and 6, so 5 squared plus 6 squared. And again, in this case, the length there is called x, so x squared. Fill it all in, 25 plus 36, which equals 61. Oh, sorry, I tell a lie. Let's keep that as x squared. Then let's put the 25 plus 36 is 61, which equals x squared. Then we can square root 61 to get x, which gives us the 7.8. which is the value of x, which is the value of that side. So two different ways you can do that, finding the longest length. So you're probably wondering what happens when you want to find the smaller length. Well, let's have a look and do that together now. So exactly the same thing. The area of this one and the area of this square and this square, so they're the smaller squares, will equal the area of this one. But I don't know what the area of this one will be yet because that's my unknown. But we do know what these two are, so let's do that. So obviously 5 times 5 again is 25, so the area of that one is 25. And 13 times 13 is 169. So the area of that one is 25 and the area of that one is 169. So to work out the area of this one, I have to do the big one, the area of the big square, take away the area of the smaller square. So if I do that, 169 take away 25 leaves me with 144. And again, to find out that individual length, well, if the area of the square is 144, I square root that to get the answer of 12. That one's quite nice. Okay, so 12 centimetres. Let's try, let me go through and do it the other way. So obviously we've got the a squared plus b squared equals c squared. Well, I know the smaller length there is 5, so substitute that in. 5 squared plus, this time is x, so let's say x squared, and that equals this length here, which is 13 squared. So again, substitute in, or simplify the value, so 5 squared is 25. Don't know what x squared is yet. Equals 169. A little bit of rearranging. Take away 25 from both sides. So that leaves you with the x squared equals 144. Square root both sides. X equals the square root of 144, which, as we just worked out, is 12. And again, centimetres. Okay, so both ways there, you can do it. Either one would be absolutely fine. This one here, you're definitely going to need a calculator. I've already done it on a previous bit of paper. So work out the area of this square and the area of this square. Well, 11 squared, or 11 times 11, is 121. And then 23.8, just to be a little bit tricky. So 23.8 times 23.8 is 566.44. So again, you definitely need a calculator to do that. I've already done it before. So if I want to work out the area of this smaller square here, I do this, the big area of the big square, take away the area of the smaller square, and if you do that, you're left with 445.44. And again, if I want to work out just that length, I square root it, and I'm left with the answer of 21.1, and again, I've rounded that centimetres. So that's the way you can work out that one there if the numbers get a bit tricky. As say again, you will need a calculator. I've already done this one before. And if I was to use the other method, a squared plus b squared equals c squared. Again, the smaller length there is 11, so 11 squared, substitute the values in. This one, on the other smaller side, is x, so x squared, and the longer length was the 23.8, but so let's simplify them. 11 squared is 121. We've still got the x squared. The 23.8, when we squared that, I said it was 566.44. Again, a little bit of rearranging. Take away 121 from both sides. So x squared leaves you with the 445.44. To get x on its own, we square root both sides. Like so, and then obviously use your calculator to work out the answer. Again, just a reminder, I have rounded this. Obviously read the question. It might tell you to round it to 1 decimal place, 2 decimal places, 1 significant figure, or whatever. So just make sure you round it to whatever the question asks. Just one little last thing, you might have noticed with this question here, where we have 5, 13 and 12, so all the sides are nice whole numbers. And for my first example here, I'll bring that back on. The first, that's not that one. My first example here, where I had 3, 4 and 5. If all the sides of a right angled triangle are whole numbers, it's got a posh word, it's called a Pythagorean triple. Just a little bit of extra there for you. Hopefully that was useful. Thank you.